Hello everyone, this is the first lesson of week 6. Our lesson today is about sending and storing. Sending and storing the waves. As you remember, in the previous lessons we were talking about waves, types of waves, and also how these waves travel from one place to another. Today we will talk about sending and storing, or another meaning for it. We will talk about how signals, how waves will be sent, and also how it will be received. We will take some examples of tools that it depends on the sending and receiving the waves. For example, telephone. Here, as you can see, telephone, radio, and TV all are forms of telecommunication, or it's what ways of transmitting information over long distances. Now, if we will take each one of these examples and explain or make clear what is the principle of this tool, we will see all of it depends on sending and receiving the signals. But this sending and receiving signals, it will be connected, or it will depend on some other parts. For example, each tool, it should contain these three parts: encoder, transmission path, and decoder. The parts, for example here, telephone, radio, TV, okay, all of these, they consist of what? They consist of encoder, transmission path, and decoder. Now, let's see, what do you mean by each part? What do you mean by each one of these parts, and how each one of these parts it works? Firstly, the first one, it's what? An encoder. Now we will take this diagram as an example. Here, as you can see, what do we have? We have a telephone. This telephone, it consists of what? Firstly, here we will have microphone. Here it's when someone will start talking. When someone will start talking, okay, as you can see here, these waves, which are, for example, which are sound waves, okay, these sound waves, it will be like absorbed by the microphone. Now, an encoder, example of it, it's what? Microphone. The function of it, it's what? It turns the incoming information, which is speech, as we said, sound waves, into a form which can be transmitted, which is electrical signal. So firstly, what we will have, here we have microphone. This microphone, we call it encoder. Encoder, the function of it, it's to receive, okay, it will convert the speech into a signal, okay, which kind of signal? It's electrical signals. Now, what will happen to these electrical signals? Now, these electrical signals will be traveled or transmitted through this wire. Now, the signals pass along the transmission path, which is wire. Okay, so the function of wire, it's what? It's to transmit the electrical signal. Then, after that, what will happen? We will have the third part, which is decoder. Decoder, which part of the telephone it's decoder? It's the earphone. This, it turns the signal. Okay, what kind of signal? It's now the electrical signal. It will turn the signal back into useful information, which is speech. Okay, again, what happened here? Speech. it will be taken in by microphone. This microphone, we called it encoder. It will convert the speech into a signal, okay, into a kind of signal that it can be transmitted, okay. What kind of signals? It's the electrical signal. Then this signal, what will happen to it? It should be transmitted through a substance. So what do we call this wire? We call it transmission path. Then at the end, this signal, the electrical signal, will be converted again into a kind of speech, okay, into a kind of useful information, which is speech. So this is what they mean by sending and storing, okay. Sending and storing, here it explains the principle of how telecommunications it works. Now here we took only one example. It was about telephone, but we will see in radio the principle, it will be the same, but with some changes. Okay, we will see what will be these changes. Other telecommunication systems use different types of signals and transmission path. Okay, different signal and different transmission path. The signals may be changes in voltage, changes in the intensity of beam of light, or change in the strength of the frequency of radio waves. Okay, they may be transmitted using wires, optical fibers, or radio waves. Another ways for sending and storing the waves or storing the energy. Here in telephone, we said we will have microphone as encoder and wire as transmission path, and earphone as decoder. But if you will have, for example, radio, it will differ. It's the same principle, but these parts it will differ. For example, the encoder, it will be how you will change this signal by changing the voltage. What do you mean by changing the voltage here? It's, for example, if you want to raise the volume of sound. So what you will do, you will turn the volume button. So when you will turn it, what will happen? Here you are changing the voltage. You are giving more voltage. Then the transmission path, for example, for sound, how it will be? It will be air, okay? Or another example, we have optical fibers, okay? We will talk later about optical fibers. Analog and digital transmission. The sound waves entering a microphone make the voltage across it vary, as shown in the paragraph above. So here, as you can see here, we have this paragraph. It shows the vary in the voltage. Here, what it's happening when the signal, or when sound waves it enters the microphone. So what will happen? It will change the voltage of the microphone. Then this change in the voltage, it will be shown as a graph. So here, as you can see, okay, here what it's happening, as much as the sound will be higher, so what will happen? The voltage, it will increase. See here, for example, it was 0.5, or let's say is 0. Then here it becomes 1, 2, 3, 4, and 4.5. So here what it's happening, the higher the sound will be, the more voltage level will be. So here this is what do you mean by analog signal. Then a continuous variation like this is called analog signal. This is analog signal, which is continuous variation. Here what is happening, continuous changing, continuous variation in the level of voltage. This is the analog signal. Okay, then the table shows how it can be converted into digital signal. Okay, digital signal, the signals represented by numbers. So here if you will look at these numbers, okay, here also it's showing the signal, but it's showing it in a digital way. So this graph or this diagram, it shows how the analog signal and digital signals can be shown. The analog, it's what? It's the continuous changing changing or variation in the signal. The digital signal, it's what? It's when the signal will be represented as numbers or will be represented by numbers. Then after that, what will happen? The digital signals also will be coded or will be shown in a way of codes. We call it binary codes. Binary codes here. This is the binary code, as you can see. For example, as you know, computer. Okay, computers, the basic of it, okay, the applications, how to build an application. So you will depend on these numbers or these binary codes. Okay, for example, 0 here, it shows 000. These 3 zeros, it represent the number 0, and here 001, it represent 1, 100, it represents the number 4, and so on. Now, the advantages of digital transmission. Here we just explained the analog and digital transmission. But here we will see some advantages of digital transmissions. For example, signals lose power as they travel along. What's that mean? When you have a signal, if this signal, while it's traveling, so it will lose some of its power. Okay, this we call it attenuation. So attenuation, it's what? It's losing when a signal, it loses its power while it's traveling. Okay, they are also spoiled by noise. Sometimes what will happen when this wave it's traveling or when this signal is traveling, there will be interference. Okay, many waves, many signals will interfere with each other, will like connect, will try to connect with each other. So to restore this power, okay, their power, sorry, and quality, digital pulses can be cleaned and amplified at different stages by regenerators. So while this signal is traveling, while the digital signal is traveling, what will happen? It will lose some of its energy. But one of the advantages of using digital signal, it's what? It's we can restore the power. We can restore the quality of it by what? By amplifying it. Okay, so when you will amplify it by regenerators, okay, this is the advantage of using digital transmission. The analog transmission also we can amplify it, but when we will amplify the analog signal, what will happen? The noise also will be amplified with it. So here what will happen? The noise will be more, then we cannot get a clear signal. So this is the main advantage of using digital transmission. So if you will have a question that it says explain what is the advantage of using digital transmission, you will say digital transmission, the signals here can be restored their power and quality. How? By amplifying it. When we will amplify it, we will get a signal with a high power and quality. Optical fibers. Optical fibers also, it's one of the way that they use it to transmit signals. For example, for long distance transmission, telephone networks often use optical fibers. As of course you heard about optical fibers now these days, for example, internet. The internet, mostly the new generation of internet now, they are depending on what? They are depending on optic fibers. So what is the principle of optical fibers, how it works, and what are some of the advantages of it? Firstly, the principle of it, it's what? Before that, let's explain how are they. Optical fibers, they are long, thin strands of glass which can carry digital signals in the form of pulses of light. So they are tubes, thin, long tubes made up of glass. They use them to transfer or to carry digital signals. Okay, what kind of signals it can pass through it? It's what? Light signal. So as we explained at the beginning of the class, we said we have encoder and we have transmission path, and at the end we will have decoder. We will see where are the encoder, transmission path, and decoder. Firstly, at the transmitting end, the electrical signals are encoded into light signal. So how it will work this one? Firstly, you will have a electrical signal. Then this electrical signal, it will pass through the optical fibers as what? As light signal. Then by the end of this tubes, by the end of these fibers, there will be what? The light signal will be, the electrical signal will be encoded, okay, by what? By using LED, okay, or laser diode. Now, at the receiving end, the light signals are decoded by photo diode. So now what do we have? At the beginning, we will have electrical energy will be sent it as light energy. When this light energy is passing through the fibers, then it will be decoded by what? It will be decoded by photodiode. Photodiode, it's at the end of the fibers. So photodiode, the function of it, it's what? It's which turn them back into electrical signal. Okay, so what do we have? We have firstly electrical signal, then electrical will be converted into light signal, then at the end what will happen again? The light signal will be converted back into electrical signal by what? By photodiode. The advantages of using optical fibers, it's what? They carry more signal with less attenuation. Okay, the most important part here, it's what? The attenuation here, it's less. It means the signal, it will keep its strength. It will not lose its energy. Okay. And one more thing, it's what? It cannot be affected by electrical interference and cannot be tapped. Storing and retrieving information. When you listen to a recording, the music is being recreated electronically from stored information. What do you mean by that? If you look at these three examples, okay, these three drawings, it shows three different devices or tools that we are using it to listen to music. What kind of music? A stored music. So here, what do you mean by storing and retrieving information? It means storing and getting back information. How? Let's take this example. Vinyl disc. Vinyl disc, this is the simplest and oldest system. This vinyl disc, it's what? It's a disc, the black disc, a big black disc. Okay, they store some music in it, then you can get it back. You can listen to it back. But how it works, the principle of it. So here it's what? This is the disc, and here it's like the pin that they will put it on the disk. When the disk, it will rotate, so this pin, or they called it a stylus, the stylus, it will vibrate. How? If you look at these grooves, okay, these grooves, okay, now what will happen? The information is recorded as a long wavy sided groove. Okay, now, when this disk, it will start rotating, this stylus, when it will pass through these grooves, it will start vibrating. When it will vibrate, okay, these vibrations then will be converted into a electrical signal. Then you can hear the sound. Another example, also, it's the compact disc or the CD. Okay, the same thing here. The information is recorded digitally as a sequence of microscopic bumps on a metal layer inside the disc. So here it's the disc, here it's the inside of disc. As you can see, these bumps, okay, or like scratch. Okay, so now what will happen? To get it back, the disc is rotated and laser light is reflected from the bumps. The reflected pulses are picked up by a photodiode and turned into electrical signal. These bumps, the laser, the light, it will strike this CD, then it will reflect. When it will reflect, then what will happen? It will, when the reflected light will be picked up, when will be picked up by a photodiode. So here what do we have? The photodiode will pick up the reflected light and it will turn it into electrical signal. So the principle of compact disc, it's how it's what? It's converting the reflected light and convert it into electrical signal. So we have light signal converted into electrical signal by the help of what? By the help of photodiode. The last example of storing and getting back the signal, it's what? It's MP3 player. Here, when we talked about the vinyl disc, this was the oldest way, or the oldest system. Now, the new one, it's what? The new way, it's MP3 player. The information is stored digitally, okay, on a microchip. This is an example of solid state storage. There are no moving parts. Instead, millions of tiny circuits are set either on one or off. Okay, so here it's what? It depends on the binary codes, okay, which is 0 and 1. During playback, the settings of these circuits are getting back in the correct sequence to produce electrical signal. So the principle of this one is as this one. If we will come back to this one, okay. So here we have analog, and here we have digital, okay, and here we have the binary code. All of them, okay, all of them, they represent the signal, the same signal but in different ways, okay. So for example, if you will have like this graph, and as this reading, you will say here it's 0, but if they will give you a number 0, also it represents 0. If you will have this code, okay, when you will have this code, that's mean it's 0. So the voltage here, it will be at this place. When you will get another number 001, for example, this it represent number 1. So what will happen? The system here will give more voltage. When it will give more voltage, so it will give different sound. So here it's the principle of storing and retrieving signal or information. All of it is what? You will have one kind of signal. This kind of signal will be transmitted. Then when it will be transmitted, it will be decoded by another part. As you saw here, we have photodiode. Here we have the 0 and 1, okay. We called it a microchip, okay. And in vinyl disc we had grooves. These grooves by stylus, it will convert the vibrations, okay, into electrical signal. Questions. Question number 1. The diagram on the right shows part of a telephone system. This diagram, it shows a telephone system. Now, A, in what form do the signals travel along the fiber? So, as we explained before, once you will hear the word fiber, so the fiber, the kind of signal that it will be transmitted through fiber, it will be light, okay. So the answer, in what form do the signals travel along the fiber? It will travel as pulses of light, okay. Always optical fibers, it's what it transfer or it transmit pulses of light. Then what does the laser diode do? So here you have microphone, then analog to digital converter, which is converting speech into electrical. Then this electrical signal, it will comes to the laser diode. So the laser diode, it will do what? The laser diode, it will change the electrical signals into what? Into light. As you can see here, what is happening, we have a signal, it's coming from here, okay, and it's going to the optical fiber. Okay, in question number 1a, we said what kind of signal will travel through optical? It will be, we answered and we said it's light. So the laser diode, it will do what? It will convert the electrical signal, okay, into the light pulse. Then C, what does the photodiode do? Okay, you should depend on these words here. Photo, what's that mean? Photo, it means light, okay. Now optical fiber, and here we will have photodiode. So photodiode here, photodiode and laser diode, these are what? These are converters. So the function of them, it's what? It's to convert signals from one type into another. So now what will happen? Here, what kind of signal it's coming to the photodiode? It's what? It's light pulses. It's optical fiber, so it contains light pulses. Now, the photodiode, it will does what? The photodiode, it will change light pulses into electrical signals. Okay, so again, it enters as electrical. Laser diode will convert it into pulses of light. Then photodiode, it will does what? It will again convert the pulses of light into electrical signals. D. What does the regenerator do? So, as we explained before, we said the regenerator, the function of it, it's what? It cleans up and amplifies signals. Regenerators, it clean up and amplify the signals. Then, E, give two advantages of sending digital signals rather than analog ones. The two advantages of sending digital, it's what? It's easier to maintain power and quality. And also you can say it lose less energy. F. Give two advantages of using an optical fiber link rather than a cable with wires in it. The two advantages of using optical fibers are, firstly, in optical fibers, it can carry more signals, and also with less attenuation. It's like the energy loss in it will be less. Question number 2. Give an example of information being stored in digital form. Which one? It store digital form. It's CD. Okay. Here the CD. Okay. In the CD we said the information is recorded digitally. Okay. Then B. Storing information in analog form. Analog form, here it's the vinyl disc. The vinyl disc, here we say the information will be stored as in analog form. Okay, so that was everything for this lesson. I hope it was clear. I hope everything was clear in it. Please, when you will watch the video, please write a comment, because till now we have many students, they are not writing any comments. So write your name so I can make sure you received the video and you got everything about the video. Your task for this lesson is to solve the questions in the workbook. One more thing, for the assignment that we sent on the e-school, so when you will solve it, please, firstly, make sure you wrote your name, and secondly, don't send it more than one time. Okay, just the first time will be recorded, so don't send it more than one time. Thank you and have a good day.